LeetCode problem number 300, longest increasing subsequence. So this problem gives us an integer array, nums, and the goal is to return the length of the longest strictly increasing subsequence. So for example here it gives us an array of numbers, and the output is 4 because the longest increasing subsequence in this array is we have here 2, 3, 7, and 101, right? So basically these numbers, but we are eliminating 5, which will give us 2, 3, 7, and 101, right? We can also choose to erase 3 in this case. This will still give us the longest increasing subsequence, but since we are only interested in the length, so either 5 or 3 would work in this case. So the way I chose to solve this, let's say I have nums which equals to these numbers, and I have another vector called list that will be storing the longest increasing subsystem, right? So let's say list right now is empty, but I want to push back the first character, the first number, which is 10. Next, I have a for loop starting from the next number, iterating through the entire list. So here, I first check if the current number, 10, or more like 9, is more than the number I have here, right? Since it is not, what I will do, this example will not trigger because 9 is lesser than 10. So what I will need to do is to update the smallest number, right? So using lower bound will basically return the number not less than the number itself, right? So in this case, that number would be 10, right? So what I'm doing here is I am updating this number, updating this list into 9, right? Okay, since 9 was lesser than 10, so that's what I'll have to do, right? Okay, next I will increment. So now we're looking at 2, and since 2 is also not more than 9, so again we have to replace the smallest number, not less than 2, into 9. I will increment once again. So now we're looking at 5. Since 5 is more than 7, no, since 5 is more than 2, what I'll need to do is just push back the number 5 into the list. Next, I will increment once again. So now we have 3. Right. Now, since 3 is not more than the back of the list again, right? Since 5 is actually bigger than 3, so here lower bound will actually return 5, right? Because 2 is actually smaller than 3, and lower bound will basically return the number not less than the number itself, which is 3. So since 5 is the next number that is bigger than 3, so what you do is replace this 5 with the number 3. What this will do is ensure the current list I have will only store the smallest number in the subsequence, right? So I increment once again. So now we have 7. Since 7 is bigger than 3, so we will just push back 7. again, since I will increment once again. So now we're at 101. Since 101 is bigger than this back, so again it will push back 101. Now I will increment one last time to reach the number 18. Since 18 is not more than 101, right? So what it will do is update the lower bound. So lower bound in this case will return us 101, right? Because again, lower bound will return the number bigger than 18 and not less than 18, right? So in this case, since we know the numbers before 101 are definitely smaller than the numbers at the back, right? So we know by replacing this number with a small number, which is 18 in this case, you will keep the current list in increasing subsequence without breaking any rules, right? So even though the example given was 237101, this is still a valid answer because this also is a subsequence that contains the longest increasing numbers, right? All of the numbers here are in increasing order. So once that is done, we have finished iterating through the nums, and we will just return the size of this list, which is 4. This answer here. Okay, let's try with another example. Let's say we have this. Our list will store the first number again. So I is now 1. So now we're looking at 1, right? Since 1 is bigger than 0, so we just push back and increment. And 0 is not more than nums. It's not more than the list back, right? Since list back is 0. So what it will do is return the lower bound, and the lower bound in this case would be 0, right? Remember that lower bound returns the number not less than, but it can return the number equals to, right? And since 0 replacing 0 is still 0, so we don't need to update anything in our list. I will increment. Now we're looking at 3. Since 3 is more than the back of the list, we will push back. Now we're looking at 2. And since 2 is more than the numbers at the back of the list, right? No, sorry, 2 is lesser than 3, right? So we cannot push back. Instead, we will return the lower bound for the number 2. Okay, now here, for the case of 2, remember that it will return the number not less than 2 itself, right? So in this case, it will return us 3. So we replace this with 2 and move on, right? So I will increment. I think we're at the last one already actually. 0, 1, 2, 3, 4, 5. Yeah, we're at the last one already. So again, we check for 3. Since 3 is more than the back of the list, which is 2, so what we do is we just push back 3. So you can see here, the longest increasing subsequence is actually starting from 0, 1. We ignore 0, ignore 3, and 2, 3. Right, so this is the longest subsequence, ignoring these two numbers over here, which will give us the answer of 0, 1, 2, 3, and the size of it, which is 4. This will give us the answer similar to the example given. Okay, hopefully you can see that the solution I've given is pretty straightforward. Other than that, that's all I have to show. Thanks.